All right, today we're going to be taking a look at section 2.1, which is called Symbols and Terminology. At the beginning of every chapter that we do, and we're going to do 6 chapters, what you're going to see is that we have a lot of just things we have to define. Right? There's groundwork that has to be set up in order for us to actually have a communication about what we're talking about and us to all be on the same page. Okay? So as we get started, we're going to take a look at our leading idea. So set theory helps us understand how elements belonging to groups and how those groups relate, how they form a part of a larger structure. In a similar way, faith in God encourages us to see ourselves as a part of something greater, belonging not only to individual communities, but to a wider purpose and design. Just as sets can overlap, intersect, or be contained within one another, all things we're going to talk about, faith invites us to consider how our lives, choices, and identities are connected within a larger, meaningful whole. And we're going to pray. Dear Heavenly Father, I thank you so much for these students. I thank you for bringing them to OBU and for placing them in this class today. I pray that as we start our discussion of set theory, that the connections that we have to our purpose and our identities in you will become clear. I pray for our class today that things will make sense and that you will give me the appropriate words today to make sure that they do. In Jesus' name, amen. All right, so what in the world is a set? A set is simply a collection of objects. Okay? These objects can be physical objects, so maybe they are like the physical textbooks on your shelf in your dorm room. But they could be something that's also virtual, like all of the songs that's in the playlist on your phone. Okay? It's just a collection of something. Those objects that it's a collection of are called elements. And there are 3 different notations or ways of describing these sets. The first one is a word description. And we're going to do an example. And it's going to be one that's got some numbers in it, but they don't have to, but just for the purposes of me showing you a connection between all 3 of these types, I'm going to do this one. So this is a verbal description. It's all whole numbers less than 7. So one way to describe a set is to simply describe it. Right, in words. Another way to describe it is what's called set builder notation. Now this one's going to feel like overkill for what I'm doing on this one, but there are places where it's not, and we'll see some places for that later. So set builder notation starts out with curly braces. Let's see how good you are at drawing those. You get better over time, I promise. The curly braces. And we're going to put a letter, and you usually see the letter X used, and a vertical bar. That bar is the phrase such that. So this says X such that. And then there's 2 things that were described above. One thing is that it's a whole number, and the other thing is that it's less than 7. So I'm going to choose to write the less than 7 first because that's just more typical, but if you did it in the other order, it would be okay. So X is less than 7. And then the other piece is that it's a whole number. And I'm going to use some notation here. Just bear with me, and I'll explain the notation on a different slide. I should probably do these slides in a different order. But this is X. This right here, it's this E that's kind of curled, almost like a C with a line in the middle, means is an element of. And this a W with 2 lines on the left is whole numbers. And then we're going to close brace. Okay? So we'll look more at those details later. But this is how this set would be described in set builder notation. And then the last one, which works really well for this set, by the way, doesn't work well for everything, is the listing method. And you use a curly brace still, and instead of actually writing this sort of weird notation kind of stuff, you actually just list out the numbers that it's talking about. Okay, so we'll talk more about the number system here in a second, but whole numbers include the number 0. So we're going to start with 0. And we're going to write every number, like the things we count with when we're children, all the way up to 6, because it's supposed to be less than 7, right? Okay, so 1, 2, 3, 4, 5, and 6. And we end with a curly brace. Now, you can imagine, that was kind of sloppy, that if this said all whole numbers less than 50, listing method is not a great idea, right? But for 7, it's great. So there's places and times for things. That middle one here is a little overkill for this. It is. but it's actually closer to things that you're familiar with than you know. So imagine all the shorthand things that you guys say and do in text to abbreviate yourself. That's what that middle one is. It's an abbreviation. It's just texting language for mathematics. Okay? Yeah?
Will we ever have to use that?
You'll have to use both of them. Yeah, you'll have questions that will ask you, and we'll see some examples. You bet. All right. There's also a set specifically called the empty set or the null set. Now the word empty is exactly what it sounds like. It's a set that has nothing in it. I know, shocker, right? There's two notations for it. One notation is a 0 with a line through it. So if you're one of those people who has a habit already of writing your zeros with lines through it, you need to stop. This 0 with a line through it actually has two notations or meanings rather in mathematics. It means null set for what we're working with here. And in algebra class, it actually means no solution. It does not mean 0 in any situation, okay? This notation is an empty set or a null set. The other notation is curly braces that literally have nothing in them. Okay? So if you have curly braces with nothing in them, that's also the empty set. You can't combine these. You can't put the 0 with a line through it inside of the curly braces. That's not going to work. Okay? It's one or the other. Pick which one, right? Sometimes it'll give you multiple choice options and there'll be obvious. One's going to be there, the other one's not. But you don't merge them together. Okay? All right, so we're going to take a look at some examples. So the directions say we're going to list the elements in each set using set notation. This should say set builder notation. Whoops, let me do that. I'm still getting used to a new technology and it works a little different than what I used to use. So this should say set builder notation. Both of the second options, let me go back over here. These are both set notation because the curly braces indicate that you're in sets, okay? But the first one here is set builder notation. This one's the listing method. So when it says set builder notation, that's what we're talking about. And then the listing method is the other one. So the first one says a set of whole numbers greater than 8 and less than 18. Cool. So for set builder notation, so our set builder notation, we'll abbreviate SB. So we're going to have a curly brace, we're going to have an X, and we're going to have a bar. It's all X, right? All numbers, that's what X is representing, is just numbers, such that we have two conditions. One condition talks about what kind of a number it is, whole numbers. The other condition talks about the limiting values, right? We're between something. We usually see listed the between parts first. So this says that it's greater than 8 and less than 18. So these are sort of the ending marks, and I can use the notation like this that goes between them. So it's telling us that the X value is greater than 8. That's why it's on the right-hand side with the opening towards it, right? It's bigger than 8, and it's smaller than 18. And then it needs to be a whole number, and I showed you on the previous screen, although we haven't talked about it at length, how to write that. We write X, we write this element notation, and we write this W. We're going to use things other than whole numbers eventually too, so that's not the only notation we're going to have. But for now, it's enough. All right, so our listing method means that we're going to do curly braces still a set, and we're going to list out the numbers that satisfy this condition. So what's the first number, if I'm going in order, that I would list? 9. And then what? 10 and 11. And how far am I going to go? 17. That doesn't look very good. Let's try that again. It's better. Okay. This is our listing method. Are we good? Okay, now sometimes they'll give you something where it already kind of looks like it's in a list. It has this little dot, dot, dot in between. And sometimes it'll even tell you like what goes in the dot, 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 like they'll be looking pattern-wise. And sometimes they'll ask you to just like write the whole thing out. Yes, sir?
Number 2, do we have to use set builder notation?
Same directions, so we're going to do both. We're going to do both. But sometimes when it has that dot, dot, dot in there, it's just telling us to fill it in, and sometimes it's asking us to write it out. This one says we're going to list the elements, so we're writing all of them out. Okay? The reason I mention it is because you need to be paying attention to the question and how it's asked, because it might be asked differently when you get into the My Math Lab assignment, right? Okay, so just like he asked, we're going to do set builder, and we'll just do it first. So we're going to do the curly brace, we're going to write the X, and we're going to do the bar. So we need to list how the numbers are being described, which it looks like that I've got what kind of numbers here? Even numbers. All right, so we need to have even numbers described. And we've got a starting and an ending point. Now, if you'd like, you can start and end with the 2 and the 22. That's perfectly fine. And X is in between. But I need different symbols than I needed before. What symbol would go in each of these places? Slightly different symbol. It's going to have an equals to underneath it. So we have the less than sign, but it'll have an equal to underneath it because it can also equal to, right? 2 is an option, whereas above, 8 wasn't, right? 8 got left out, but now 2 is included. Now, there isn't any notation for even numbers like that W for whole numbers, so we simply say X is even. That's our best option here. Yes, sir?
I don't know how it's
You don't get how it's even? All of these numbers here are even numbers. 2, 4, 6, 22. They don't have to be, they just are on this one. And so we want to make sure that when we describe it, we're not including like 3 or 17 because it's not being described here. Because it can equal it. It's an or statement, which means we have either option. So it can be bigger than 2, but it could also be equal to 2. Yep. Okay. Listing method. We're going to start with 2, and we have 4, and then we have 6, and then what happens? 8, 10, 12, 14, 16, 18, 20, and 22. Okay, makes sense? All good so far? Okay, the question I think in my math lab that kind of corresponds to this is they're going to give you like a matching set where they give you like 6 or 8 or something like this, different sets, and then they give you like the verbal description for them, and you're trying to match the verbal description with the set builder notation, or the verbal description with the listing method. That's kind of what it looks like in there for this particular one. All right, so be prepared for the fact that it will look a little different than this one, the way I've presented it. All right, we're going to use set builder notation for this next one. It says we have the set of all rational numbers. Now that's not whole. So what are rational numbers? Again, we're going to talk more about these at length in a sort of a general statement, but rational numbers are things like fractions and decimals, okay? They include whole numbers as well, and they include negatives and positives. They include all of those kinds of numbers, but they're a much broader category of numbers than either even or just whole, like we've already seen. So set builder notation is the only way we can write this. You cannot list out all of the fractions and decimals, positives and negatives, and things like that's ridiculous, right? Like it's not even possible. We have to have set builder notation for this if we're going to list it in any other way. So here's how it looks. You got the curly brace and you got your X and you got your such that. All that's the same. Then we have to tell it that they're rational because there's nothing else that they give us. They don't have a less than or a greater than or only part of them. They don't have any of that on this one. So just like on the other ones, we say X. And we have that element symbol. X is an element of rational numbers. You might think R. Who thought R? I would think R if I were looking at this. I mean, we did W for whole, R for rational. Well, the problem is that R is used for another type of number. It's called real numbers. So we can't use it here. The letter that we use is actually a Q. And there's a good reason. Q is for the word quotient. You've heard the word quotient before. Quotient means division. Okay, so why does that relate to rational numbers? Well, because division is the same as having a fraction, top and bottom. That's where the Q is coming from. It's for quotient. All right, so what we're going to do next is we're going to actually build that picture of the real number system that I've been referencing. These are all the types of numbers that we're going to encounter, and maybe a couple that we're not going to be quite encountering, but without the complete picture, the rest of it doesn't quite make sense. So let me first just give you the symbols for each one of them, okay? A lot of them are just the letter. Natural numbers, it's the letter N. Whole numbers we've already done, it's the letter W. And rational numbers we've already done, it's the letter Q. I already told you real numbers is R. So we just have 2 more to fill in. Integers is not I. It's kind of stinky, but it's not. It's actually the letter Z. And it's based on Latin. Okay? It's the letter Z. And irrational numbers is also not the letter I. In fact, it doesn't even have its own letter. That's kind of dumb, right? It kind of is. So here's how we write it. We write R, that's real numbers, minus Q. So we take the real numbers and we remove, that's what subtraction does, right? We remove the rational ones. So what's going to be left? Irrational. Okay? My daughter Cam was talking about being nonchalant about this school year. We were like, I think you need to be, like more concerted and focused on your grades. She was talking about her relationship. She was like, okay, well, I'll be chalant about my grades. And we're like, it doesn't quite work that way. That's not a real word. But that's what she was trying to do, right? She was trying to take away that non part of it. It actually comes from, I think, French is what we decided. It was a French word. But when we take away that ir, right, from irrational, we get rational. So that's what's happening here. We're taking away the real numbers and we're starting with the real numbers and we're taking away the rational numbers and we're left with irrational. So we're going to draw a picture of what this actually looks like. Okay, so I want you to draw, you've got a lot of space on your paper. I don't have a lot of space on my screen, so I'm going to have to go to another screen. Nope, I'm not. I'm just going to squeeze it in with what I've got. Okay, you're going to draw a big rectangle. And you need to draw your rectangle, like split it in half, but it doesn't have to be equal halves. You're going to write a whole bunch more in one side than the other. So I'm going to split mine like this, not because it really indicates size, but because on one side I got a lot more to write. Okay, everybody cool so far? Inside the bigger side, I need you to make 3 embedded rectangles. Let's try that one again. I need it smaller. Okay, so it starts to look like one of those like puzzles that messes with your eyes. It's not what it's really supposed to look like, but it kind of does. Okay, the tiny little one that you have in the middle, that's the natural numbers. So right in here is N. I'm going to label them and then I'm going to describe what they are above N. So our natural numbers are the ones we naturally count with as a child. When you first learn to count as a child, what number do you start with? 1. So the natural numbers are 1, 2, 3, and so on. Very quickly, you realize you need a number that's 0, right? Once you include the number 0, you have the whole numbers. So they're almost the same, but whole numbers include 0. That's actually a really important note. Just highlight it if it's something that you're not super familiar with, because students consistently mix up which one has a 0 and which one doesn't, or they leave it out when they should include it and so forth. Integers is the next rectangle out. That's the Z here. Integers include the positive and the negative whole numbers. So we go like -3, -2, -1, 0, 1, 2, and 3, and so on. The next rectangle out from there are the rational numbers. Those are all of our ratios. Okay, so for rational numbers, I'm out of space, I'll write it down here. Our rational numbers are things like, so these are examples, 1/2, -0.7 repeating even. You can even have repeating ones. You can have 3/17. 3/17. But it also includes everything inside of it too, right? So like if you're a rational number, right, you don't have to be written like this. You could be the number 3, because the number 3 can be written as a ratio, 3/1. So 3/1 is a rational number, yes. Yeah, it's fine. And then the other side, the other side is our irrational numbers. So it's the R minus Q. What are those? Well, they include things like, again, these are just examples. Square root of 2. Pi. You've seen that one before. And maybe you've seen the number e. Maybe not, but that's another irrational number. Now, just because something's a square root doesn't mean that it's irrational. Square root of 4? What's the square root of 4? It's 2. It's a rational number. Okay, so it's just because there is a square root doesn't mean that it's irrational. It's a square root that can't be simplified into a whole number when you're done. Okay? And all of these, this whole picture is the real number system. Okay, so sometimes we like to be able to say how big a set is. The set's size, how big it is called its cardinality. So it's just the number of items that are in the set. The notation is an N in front of it and then the name of the set. Okay, so yes?
What about cardinal?
That's what it is. Cardinal number and cardinality, they're used interchangeably. Cardinal number and cardinality. So on the example, it says find n of a. So if you see n listed, n with the parenthesis, it's asking for the number of items. If you just see it say describe a, it's actually asking you for the list of items in some way. But once they put that n in there, they're talking about number. So we have a list on number 4 next to the letter A, and it says it wants us to find n of A. You can count this one pretty directly. How many numbers are there in set A? There's 7. You guys are whispering, but yeah, it's 7. It's just counting, right? This is not a trick question, right? Now, number 5, that A, is a little harder because it doesn't list all of them out. So if you wanted to actually list them out first, you could do that. Or if you just want to count them out on your hand, that's fine too. It's not just 4 numbers. Like there's 4 numbers that are written here, right? 5, 10, 15, and 50. But the dot, dot, dot in between means that it's including all the ones in that pattern that are in between there as well. Okay, so I see some of you counting. That's good. How many did you end up with? 9 or 10, depending. You should have 10. Okay, if you got 9, count them again. Did everybody get 10? Yeah. So there's 10 items that this set is describing. And while we're nearly done, we're not quite done, so we're just going to stop right there for today, and we will pick up here on Tuesday. All right?